today. My name is Ioannis Tonkos, and I'm with University of Patras, serving as coordinator of this project. So this is the overview of what I'll talk about, the overall scope of the project, the consortium composition, the coordination structure, the innovation areas where I will focus a bit more, and also on how we plan to implement the objectives of the project through our work plan, focusing on the key project objectives and the related KPIs. This is actually the overview of what we are planning to do during this project. We focus on how to support end-to-end networking in the future 6G networks by putting the emphasis on the X-hole part of the network, which of course relies on optical networking technology. As you can see here, we have the end-to-end 5G network, starting from the RUs going all the way to the CUs. It's a decentralized open RAN architecture, as we're all familiar with. However, in order to connect the end users with the operators and the data centers where the traffic is located, we have to deploy a very advanced transport network consisting, of course, of access routers, aggregation routers, metro and core routers that interconnect with an advanced optical communication infrastructure consisting of reconfigurable optical address multiplexers and cross-connects that have very high rate interfaces in the range, as you can see here, of 10 terabit per second in the future. Currently, we are at 0.8 terabit per second, and we want to scale up to 10 terabits. This brings the link capacities to several petabits per second, and the node throughput capacities to beyond 10 petabits per second. So in order to realize such connectivity, we need to use the latest advances in optical communications and networking systems, which rely on new multiplexing techniques like ultra-wideband and space division multiplexing. And with the associated developments, we hope that indeed we will be able to resolve the bottleneck issues associated with the X-hole part of the networks. So this is our consortium. As you can see, we are about 15 partners having representatives from many major companies, but also SMEs and a few research centers and universities coming from all over Europe. The budget of the project is close to the specified target of 5 million euros. In order to ensure a proper management of the project, we have assembled a project coordination team consisting of the coordinator, the technical manager, but also exploitation, dissemination managers, and the work package leaders. So here you see one by one the key innovation areas where we would like to focus on. The first one is, as I said, and that's the name of the project suggests, to support flexible scaling of the X-hole network. In order to do so, we need to utilize all available resources we have in the network, including spectral resources. So we plan to utilize the entire bandwidth available in optical communication systems, which can go up to 300 nanometers. Then, of course, we plan to operate at the highest possible baud rate. At the moment, we're at about 190 gigabauds, but things are improving. And also, we plan to utilize the most advanced modulation formats. And for that purpose, we try to focus on the development of advanced transceivers. Then, Since we want to interconnect at these routers I mentioned before, the traffic across the network and reach every user and at every cell site, we develop novel optical switching architectures like this one you show here, which goes beyond what is currently available by network operators. Today, we're mostly using conventional optical cross-connects, performing fiber switching, which is a part of our architecture, but also wavelength selective switching, which is also a technology that is used to perform, to exploit the resources at the wavelength level. However, with our project, we are also introducing a new waveband selective switch element.
We seem to have lost Ionis's voice. Are you still there, Ionis?
Developing during the project. This
Sorry, Ionis, we missed you for a couple of sentences there. So
okay, I'm sorry. So I'm saying that this node and ad-hoc multiplexers needs to be equipped with advanced interfaces supporting ultra-high bitrate transmission. And this is the third innovation area we are focusing on. We're developing transceivers that can implement very high-order modulation formats, as you see here, up to 56 QAM constellations, but we develop new approaches for implementing these transceivers, which relies on the removal of bandwidth-limited and power-consuming electronic DACs, and we're replacing those with optical DACs performing direct digital optical conversion. We have already some really amazing results demonstrating a significant improvement with our approach, as you can see in the right-hand side of this figure I'm showing, compared to the conventional approach for transmitters generating such signals. We achieve significantly better EVM and, as you see, noise squeezing effects. We have a fourth innovation area which focuses on how to control this infrastructure, so the optical switching nodes, but also the interfaces of these nodes. And to do so, we have developed an approach for controlling all this infrastructure with individual SDN controllers and an SDN orchestrator to bring together all these elements of the network. Finally, as a fifth innovation area, we focus on how to implement additional ways of securing the network transmission, the data transmission, and also how to support in a better way the surveillability of the network. To do so, we plan to deploy across the network performance monitoring equipment and utilize them in order to, through also machine learning approaches, in order to make sure that the data are transmitted securely across the network. So we have organized our work in several project-wide objectives, as you can see here. I will not go into the details. All these objectives are associated with the key innovation areas I just presented. However, I want to emphasize that for each one of these objectives, we have defined specific targeted KPIs that, as you can see here, are very well defined in a measurable and verifiable way. So here are the key objectives related with the main innovations of the project as I described before. This one focuses on this optical switching architectures we're developing and the associated new elements we're introducing. Those need to have certain specifications as shown here, and currently we're investigating how we can actually achieve those with the technologies and the partner capabilities available. The other major objective, as I mentioned, is to support the development of 10 terabit per second capable optical interconnects that achieve this capacity in an energy efficient way. So quite challenging target, but we have the technology and the ideas on how to implement those. To do so, we develop novel technologies, novel optoelectronic devices that are capable indeed to realize this ultra-high data rates. On the control and management of the network, first we are in the process of developing novel algorithms that can orchestrate the network elements and handle the traffic that needs to flow across this network in an end-to-end way, as I presented at the beginning. And of course, we have a plan to deploy a final testbed. We operate at the beginning at TRL 2 and 3, but we want to reach at the end TRL 3 and 4, at least for some of our key elements. And finally, we have objectives associated with the exploitation and dissemination of the projects so that people will know what we are doing and how we plan to promote these outcomes towards commercialization. Of course, we have a defined work plan with work packages that are divided in certain tasks, and all these are interacting together in order to realize the work plan. I will not go into the details about this. It's something very usual for all projects. However, I would like to emphasize that we have defined very specific also objectives for each one of the work packages and the associated tasks and how those can lead to the deliverables we have to provide to the Commission at certain dates. And we are closely monitoring progress. Some activities have already started and are well underway. And this is ongoing across all work packages at the moment, where we have regular phone calls at the plenary level, but also among individual partners. And this goes on, as I mentioned, for all associated work packages. The goal is at the end to bring everything together at the final testbed we're developing to integrate all elements at the data layer, but also at the control plane layer, and demonstrate the operation of these subsystems and these innovations we're developing. For us, it's very important to make sure that at the end of the project, we will have patented innovations, and those will be capable to reach the market within a couple of years after the end of the project. Already, we have good indications and filed patents that makes us believe that the project will have a big commercial impact in the future. To make sure that we implement these targeted outcomes and impacts in the future, we have devised a plan starting from the work we're performing at the work packages. We have already identified key results that we're trying to implement currently, and then a plan on how to take these outcomes to the market through, of course, the activities of one of our work packages focusing on the dissemination and exploitation activities associated with our project innovations. And with that, I would like to thank you very much for your attention on behalf of all project partners that you see over here. Thank you very much.